for these. Graphing's faster, more visual. The calculus is not that difficult, but it is more steps, more time.
Let's graph it.
Okay. So if you're okay with that, I'll graph it in another window and I'll snip it in. Now, the important thing here is that when you're graphing it, you have to restrict it to -6 to 7. So you're not graphing the entire thing. And that's where we're going to see some potentially interesting behavior. We'll find out here shortly. So let me -6 x less than or equal to 7. And then why is that? That's not right. All right, can you just all right. So the biggest challenge is just framing it in the right window to make it so that you can see something. And we have it here. Okay. All right. All right, so here we go. I've got the graph of it, and the graph is critical because it tells you everything, just like in the previous problems here. So we can see that in terms of the min and the max, we've got them here. We've got those points on the graph. So let me just look and see what it's asking for. Yeah, so it's asking for the absolute max, and it says is. Let me snip that in so we get it clear. Oh, and they do allow you to round. That's nice. Okay, so it says the absolute maximum is, and the absolute maximum is that 90.83. And it's just rounded 2 decimal places as needed. And then it occurs when x equals -5. And then similarly, you can find the absolute min doing the same thing here, where the min is -131. It's nice number, and occurs at x equals 6.
Okay.
Any questions on that?
Mm-mm.
All right, so for the next one, I'll do the same thing. Let me snip it in. Snip it in here. And as always, if there's any changes on your side, let me know. Hopefully there aren't any. But same thing here. So I'm just going to graph this function in that window, -4 to 4. That helps us to limit what we're seeing. 36x squared plus 5. All right. And then what's really nice with the technologies, I'm just clicking on the mins and the maxes. It already knows to look for them. It feels like this is the way it should be taught, because you just get the number right there. Okay, so there's your graph, and I didn't get the endpoints, but you can see the endpoints are not a max or a min. They're just in between points. They're not interesting. They're not your destination. So in terms of how to answer it, again, the absolute max occurs. Maximum is 5, so it's the y value. It's the y value at this point, and it occurs when x is 0. And then similarly, no rounding needed for that one. Similarly, there min. Now it does say use commas to separate answers, so you can have more than one min or max, but the absolute min is -157, and it occurs at x equals -3, comma 3. And so with the graph, it just tells you so much about these things. And calculus really is about interpreting curves. All right, so let's look. Got another one here. All right. All right, so I'm gonna go to my other screen and graph it. This is a rational function, so it's gonna look a little bit different. It's not gonna be as nice and smooth as the others that we've been looking at, but a lot of actually pre-calculus students right now are learning to graph these things. You almost want to tell them like, hey, we should just go right to the
Totally.
Yeah, but they're supposed to do it by hand. So um, yeah. So this one, let me change the window slightly. Yeah, that'll be a lot easier for us to see. All right. All right, so the windowing is really a key part of this, because if I didn't kind of get the change the scales, it would look almost like a straight line. But you can see that there's a max there and a min there. This one didn't give it to us, so the min occur. I'm sorry, the max occurs when x is 0, and to get that value, you're plugging it back into the original equation, so you get y equals 9/5 or 1.8. And then for your min, it's when x equals -5. And you could substitute that in, but on the curve there, it's y equals -0.4. So let me snip in the answer space here. So the absolute maximum is 1.8 when x is 0. And the min here. Min is -0.4 when x equals -5. So from on this problem, what you should notice is that it sometimes is at the endpoints of the window,
Mm,
whereas in the previous problem, the endpoints were useless. There was stuff going on in between that was more important. So it depends on the problem. It depends on the graph. Could be at the endpoints. Could be neither.
okay.
All right. So it looks like we're up to question 6. Question 6. Total profit in thousands of dollars from the sale of X 100,000 automobiles is approximated by this function where X is greater than 5. So that means it goes from 5 to infinity. And they want the maximum profit. So again, you could use your calculus to take a derivative, set it equal to 0, but we're just gonna graph it and take a look at the function here. So give me just a moment here to get that graph going.
Mhm.
I doubt in your world you ever look at graphs of profit functions, but maybe I'm wrong.
I would say no.
Okay, yeah. So it's a little odd that they're like, yeah, here you go. Here's your profit function. So let me window this correctly. Let's go 0 to 10. Okay. These are all designed, for textbooks, for students in classrooms. So they have to make the numbers nice, and they are generally always work out, where there's not really a weird situation. But this is what the graph looks like. You can see I started it at 5. I didn't let it go from 0. And the maximum profit is right up here at the top. Now there's a little bit of weirdness with the units. So it says it's 896, but it's in thousands of dollars. So your profit is 896 with 3 zeros there.
Mm,
And then because X is already in 100,000 automobiles, that is your X right there. Your X is 12, but your profit is this other number here. All right. Next problem here. Marshy region used for agricultural drainage has become, okay, there's a lot of words there. We need to find the derivative of this function right here.
mhm,
And I would actually divide both of these by 4x first. So x squared over 4x plus 64 over 4x. And what that does is it makes taking the derivative easier. It ends up being x over 4. I'm sorry. Yeah, x over 4 plus 16 over x. And so your derivative, believe it or not, is 1/4 minus 16 over x squared. Okay, so that's your first box there, and that's just power rule. We haven't done it in a week, but it's just power rule. It's not anything more complicated than that. Okay, so you get that entered into the space there, but whenever it wants a min or a max, you just graph it, and you can choose to graph the original, which is what I would do, just in case you make a mistake with your derivative. You always go back to the thing that is true. In this case, the original function, and they give you a window. They say from 1 to 12, so that's also important here. So let me get this going. X squared plus 64 over 4x, and that's good from 1 less than or equal to x less than or equal to 12. And then we'll change our window. Zoom out just a tiny bit more. Okay, here we go. All right, so here's the graph, and the graph tells you everything. It tells you that there is, let me see if I can put it up here next to the problem. You can see that there's a min right there at 8,4. So we just got to figure out where the 8 goes and where the 4 goes. So we got to go back to the problem. It says X months. Okay, so that the X value is the months. So that's 8 months. And the minimum percent of the element will be. So let's see what's going on here. Found the percent of the element to be. Yeah, so I'm guessing the answer is just 4. This is one of those where I don't know whether the answer is 4 or 0.04. Because it does say to round the nearest hundredth as needed. Let me look this problem up and see if there's some clarity on that. Build up bounds from the percent of the element. Minimum percent. Huh. So I guess I would go 4. I don't feel great about that, but I don't think it's 0.04 because it does say it's a percent in the problem. So we'll go with that.
Yeah, I'm good with it.
Okay. All right. Next problem here. All right, so the first thing it asks for is the derivative. For some reason, they're using capital F, which is odd, but the derivative, just like we've been doing, it's power rule. So you take that 3 in the x cubed and you bring it down. So it's minus 3x squared plus the 2 times the 3 for the next one. So that's 6x. Whenever you have a number times a variable, just the variable is just the number, and the derivative of a constant is 0. So this is your derivative right here. Now to answer the next part, you're supposed to set the derivative equal to 0, find the critical points, evaluate them and the endpoints, but we can get all of that information from the graph. So I'm gonna go ahead and do that now. The derivative is restricted. So like if you restrict one thing, and you know this from the real world, like you can't, the next thing is also restricted. It's not as if it's free to do whatever it wants. So let me get the graph going here and we'll look at it. Then we're going from 4 to 18. And then I have a terrible window. So let me get this back. Right, so here we go. All right, so let me snip this in. So again, I'm graphing the original function, not the derivative. The derivative could be useful, but you always go back to the original and graph. So you can see there's a max there. So if you ever were to do this problem and you got like a min instead of a max, you made some sort of mistake. So your information should all be consistent. So the number of fish is given this. Now we're just looking to make sure X is the temperature. So it looks like it's X is 12. No like modifications of it, needed. It's not in like something else. So just 12 degrees, just that X value.
Okay.
So sometimes they just ask for the X value. Sometimes they want the Y value. Sometimes they want the derivative. And that's this part of the course. And this part is really tough for most students because they're like, well, what do I need? And that you have to interpret like what the X is, what the Y is. And it's usually in
Right.
terms of profit, revenue, cost, things like that, which are really important. But as a college student, sometimes you're like, why do I don't, it's not in context, but that's where we're at. So, okay, here's a function again. And it says that it's telling you there's a max and there's a min on this window. So again, I'm just going to go and graph it, and hopefully that tells us all the information that we need. And give me just a moment to do that. And you could do this on a TI, 83. It really is it's not the technology that I'm using. It's just if you can actually graph it, it answers all the questions that you need here. So minus 0.015x squared plus 1.42x minus 7.3 from 30 to 60. Where is my graph? There it is. Okay. All right. Okay. Is this a rounding problem? Yeah, it is. Okay. All right, so I'm snipping in the graph now. So when you look at the graph here, it looks pretty shallow. If I scaled it slightly differently, you might see more of like an up and down, but this is definitely the max up here. And somewhat reasonable. I don't know what you drive, but so cars can get this many miles per gallon. Not all, maybe most don't. Nearest thousandth. Ooh, okay. So 333. And this occurs, wait a second here, I got to get the right number. So maximum miles per gallon. Okay. So, so I've flipped these. This is you got to look at the units. So X is
Yeah.
miles per hour. So that's not so good. 26.307. Okay. That is the output. So that's the Y is the miles per gallon. And then the minimum. So the minimum could actually, it's either at one end point or the other. And you can see the one on the right is slightly higher than the one on the left. Okay. And then I guess I should just double check it. It does occur at 30 miles per hour. The question is whether it's really that nice of a number. I guess it is. But I can, so what I do when I see something like this in the graph, because I don't know if it's rounding it, it's really like 0.799 or something like that, is I just plug that into a calculator. So okay, when X is 30, go back to the original function and just plug it in for X. And let's see if it actually is exactly that. And it is. It is 21.80.
Okay.
So you're probably aware that speed limits were lowered during the oil crisis of the 70s because of this, because cars got better fuel mileage when they went slower. That was one of the reasons they lowered them. You don't see it today, though.
Right.
I think that would cause a major
Outrage.
Yeah. Not that people observe the speed limit anyway.
Right.
So let's see here. So that's the answer to that one. moving on to number 10. All right, so here we go. This one's got a bunch of parts, so I'll snip it in pieces. Oh, they're trying to get you to step through it. I see. All right, so it says here, follow the steps to find the non-negative, that's important, non-negative numbers x and y that satisfy the given requirements. Okay, so they're saying the two numbers have to add up to 180, and then the product is as large as possible. So as a kid, you're like, well, what if it's 0 and 180? And what if it's 1 and 179? And so on. And that takes forever. But they're trying to step you through how to do a problem like this one. Okay, so they're saying the first thing you do is take this first equation and you solve it for y. Well, you get y by subtracting x from both sides. So it's 180 minus x. Okay, so that in terms of what you put in that first box, it's all of that. So whenever it says equation, it's expecting a letter equals something on there. And this actually works out better when they make you enter the answer and then move on to the next step, but they're giving it to you all at one time here. So now they're saying take your answer from part A, take 180 minus x and plug it in for y. So it's x times 180 minus x. Okay, now you could simplify, you could say, okay, it's 180x minus x squared. I think it'll take either of these. Really don't know for sure, but one or the other goes in that second box there. Now, in terms of the domain, the two numbers have to be non-negative. Okay, so we sort of started this list 0 to 180. We could go all the way up to 180 and 0. So basically, the numbers have to be between 0 and 180, and that's this part C, 0 to 180 with parentheses. It could be anything between. Actually, I take that back. It could be both. So we'll put brackets there. Brackets mean it could be the endpoints. All right, so now for part D, it says to take the derivative of the following. So your equation is 180x minus x squared, and they want the derivative. dp dx, excuse me, means to take the derivative. It's just power rule again. So it's 180 because it's the coefficient of x minus 2x. So that goes in your first box. The second thing they're asking you to do is set the derivative equal to 0 and solve for x. Okay, so to do that, you just manipulate things around here and you get x equals 90. There's only one answer for this. I don't know why they say comma, separated answers. Okay. There's more to do, just grabbing the next part. This is actually this series of steps that you're supposed to do for all the problems that we've been graphing, if you're doing it the calculus way.
Yeah. Okay.
It's stepping you through what you need to do. Okay, there was only one solution to part D, and what they're saying here is take that value of 90 and plug it back into the original P, into this P right here. Okay, so that's the thing that you're graphing. So it's P equals 180 times 90 minus 90 squared. And that gives you a number. Make our calculator for that. 180 times 90. That's 8100. So that's that box there. So then evaluate P at the endpoints. At the lower endpoint, so so the lower endpoint is when x equals 0, and at the upper endpoint is when x equals 180, and that comes from the domain. That's from this part right here. So they're saying like you also need to check the endpoints. So when you put 0 in for x, and both of these, when you're putting them back in this p equals 180x minus x squared, they end up being both being 0. Okay, so here's the summary. So the summary of this is you're supposed to do the following. You're supposed to say, okay, p of 0 is 0, p of 90 is 8100, and p of 180 is 0. Can you give me just a moment, please?
Mhm.
All right, thank you. So the point here of all this is you're supposed to look at these three numbers on the right, and you're supposed to, like, I could ask a 6-year-old this and say, which is the biggest? And they would say 180. That's your max. And and I'm not trying to be, disrespectful to you, I'm just saying, like,
Oh yeah.
once you do the calculus, like, it's not that difficult. You just look for the biggest number and the smallest number, and that's it. So it's the profit is 8100 when x is 90, and then to get the y value. And that's why this is so hard for students when they're saying, it's like, wait, I got to go find y. Where is y? Well, if you remember, the original equation was x plus y equals 180. So if x is 90, then y must also be 90.
Okay.
Oh goodness, we got one more just like it. All right. Let's keep going. There are some, actually, these are all considered optimization problems. And there are some really interesting optimization problems out there. But these are not it. These are the ones that are, but the ones that are interesting, if you ever look about why, I'm sure you've bought canned goods before. The actual optimal label on a square can is square, but the square can is ugly. Let's see if I can draw a square can. That's more of a square can. That's visually ugly. And this one adheres to the golden ratio, and that's why, one of the reasons why it's preferred on the shelves, believe it or not. So the math tells you make a square can. It's like if you ever buy like peanuts or nuts, they don't adhere to it apparently, but
like soup.
Yeah, soup.
Weird.
It's got to be like this. So you'll notice even when it gets bigger, they use the same proportions. So
yeah.
But the math says otherwise. It says do not do that. But that's a marketing thing.
That's funny.
All right. So again, the same set of steps here. You're solving this equation for y. Y equals 99 minus x. So you got to be careful here with this, online stuff. It's just that part. It doesn't need the y equals this time.
Right.
So then you're substituting it in for y, 99 minus x. So I believe it'll accept this, but I'm going to distribute because we'll use that for the derivative. It'll take one of those there, 99x squared minus x cubed. All right. And then in terms of domain, it's set it above, and it's kind of the same thing as the previous problem. It's generally non-negative. Let me look and see if it said it. Yeah, it does say non-negative. So your domain is from 0 to 99. Again, and you also get it from the function. You realize that 0 causes the whole thing to be 0, and then 99 also causes the whole thing to be 0. We don't have to be that rigorous though for what we're doing. So we'll just kind of just say, okay, it can't be negative, so it's got to be 0 to 99. And that's your part C answer.
Okay.
Part D says to take the derivative of this thing, but it's actually better to use the expanded form or the distributed form. So it's power rule again. You're going to take the 2 times the 99, 198x minus 3x squared, and that is your derivative. For the last part here, you have to set the derivative equal to 0. And so you try to factor out as much as you can. So 198 is divisible by 3. If you add up 1 and 9 and 8, it ends up being a multiple of 3. It's 18. So we know that 3 goes into both, and there's an x in both. And then you can just divide using a calculator, or if you know it. I'm struggling to know it. So let's go 66. Does that seem right? I was working with a student earlier and I fumbled a factoring. It was just totally off. I was like,
No, you're good. It is 66.
it's like, I check these things. So now this is where you do have two answers, because it could be that 3x equals 0, or 66 minus x equals 0, and x equals 0, or x equals 66. So where the derivative is equal to 0, these are what are called critical points or critical numbers. And they're important. So in terms of your answer here, it's 0, 66 in the box there.
Okay.
All right, so it says evaluate P at any solutions found in part D. So notice they actually give you the answers to some of this.
Oh,
They tell you, yeah, it's
right.
kind of neat. So you're going back to the original. You're going back to what you started with, which is the answer to part B. And that's where this, like, well, which do I go back to? It's this, x squared times 99 minus x. Okay, so a few of these are easy to evaluate. So at 0, it's 0 because 0 squared is 0. At 99, it's also 0 because 99 minus 0 is 0. Anything times 0 is 0. So you really only have to evaluate it at the 1. And you'll definitely need a calculator for this one. And see what we come up with here. So I get 143,748. Please check that.
Yeah, give me just.
And then there's part F. So part F, hopefully we don't have some different numbers in this one. It doesn't change that much, but just go through it again. So the maximum value is that 143,748. You do not enter it with the comma, and it's when x is 66. To get y, you have to go back to whatever the original relationship was between x and y. X plus y equals 99. And x and y is 33.
So P, you said don't type it with a comma?
Yeah, I think I maybe gave you that impression in a previous problem also. Commas are bad.
Oh, really?
Yeah, I don't know. I don't remember. Like, just be careful. Yeah, sometimes I use commas, sometimes I don't.
So for like part E, P66, I should get rid of the comma.
Yes, do not use a comma for that.
Okay, and then X is 66 and Y is 33. Whew, that's a lot.
If you think about trying to explain to a kid like when to use commas and
Yeah.
how to like, it's very confusing, like how to say this word or this number. And because there's actually a couple ways to say it,
Mhm.
it's weird. I don't envy that because it probably could be a better way to do it. All right. On to the business calculus stuff here. All right, looks like we're up to number 12.
Mhm.
All right. The price charged for a candy bar is PX cents. That's important because we're probably going to do it in dollars. Okay. Maybe not. Okay, so revenue, part A is revenue. Revenue is price times quantity. So
Okay.
your X is your quantity. So you take your price function and you multiply it by X. Having said that, though, I'm really bothered here because it's in cents
Mhm.
and revenue is always in dollars, but doesn't say that revenue is in dollars. Let me confirm this question online. Because like I'm thinking we should multiply by 100 is the,
Mhm.
but I don't see that for this. Maybe you convert it at the end. So we're going to go with this for now. You can either enter it. This is part A that I'm boxing in, or you can distribute and get 167x minus x squared over 10. Those are also correct for A.
Mhm.
And then I'm going to go to the graph. I'm going to graph this again.
Mhm.
When you graph the revenue function, let me get that here, 167, 10 times x. So these are almost always quadratic problems. It's kind of interesting. Whoa. Uh, all right. Okay, so I'm snipping in the graph now. All right, and we're looking for the X value that leads to the maximum revenue, which is 835. And that looks consistent with what I'm seeing online. It's some number like this.
Okay.
Now, the revenue is in cents. So this number here, this 69,722.5 is in cents. So you have to move the decimal left 2 places. So the answer would be 697.225 because that's dollars, not cents. Oh, I really don't like this one. Really. See if there's another. X thousand candy bars though. So okay, but I didn't take that into account either. So this is wrong. So it's oh, but it's X thousand, but that's in cents. Uh, I guess I would try 697. I don't feel great about that, but because it doesn't say to round,
Mhm.
but you can give that, you can go with that. Um, problem here. Okay, let me keep going here so we can get through all this. All right, so a fence must be built to enclose a rectangular area of this square footage. So you've got something like this. It's good to label X and Y as reasonable there. Now they're telling you that the total area is 5,000. And they're saying three per foot for the two sides facing north and south. So that's $3 and $3 and $6 on the other sides. Like that. Okay, so you're trying to minimize the cost, and that's key because you got to figure out what's the cost. Well, the cost is your perimeter. So your perimeter is X plus Y, but it's the multiplier of the money. So it's like 6Y plus 3X plus 6Y plus 3X. And so you're trying to minimize this 12Y plus 6X. And the problem is it's got two variables in it. So that's why they give you the area. They say the area is 5,000. 5,000 is X times Y. And so just like we did in the previous problem, you're going to solve for Y. So Y is 5,000 divided by X. And that's what goes into this right here.
Mm.
So you always get two equations and you solve one for Y and plug it into the other. So it's 12 times parentheses 5,000 over X plus 6X. This is your cost function. And this is what we can just graph. Now, normally you would take a derivative, set it equal to 0, but this will give us the answer that we're looking for by graphing it.
Okay.
And then because it says here, I guess they're sort of hinting at the answer. Oh boy. Excuse me, why? I wonder if they meant for these variables to be flipped. It should not matter. So the answer is not a nice number, and that's what I'm concerned about because it should be. Oh, I see what problem is. I messed up. Not that. Okay. Now it is a nice number. Okay. So the graph shows, just to save some time here, the graph shows that when X is 100, it ends up being a min here right at 100. Okay. And then because I'm graphing the cost, it also gives me the Y value there. And I'm helped out because it says simplify your answer. It's trying to say, hey, it's a nice number there. So,
Okay.
so when X is 100, Y ends up being 500. And if you put those numbers in here for your cost function, you'll end up getting 1,200 for that. All right, a rectangular tank with a square base and an open top and a volume of 32 feet cubed is to be constructed of sheet steel. Find the dimensions of the tank that has the minimum surface area. Square base and an open top. So they're saying your base is a square. And it goes up like this. And then there's an open top like that. So you have X, X, and Y as your dimensions.
Mm-hmm.
So your volume is X squared Y. It's base length times width times height, X times Y, and that equals 32. Okay. The problem again is you got two variables, but that's not what we're trying to do. We're trying to minimize the surface area. So the surface area is the kind of the wrapping around like each sheet. So there's four of these XYs. So XYs is like the right side there. There's four of them because it goes all the way around.
Mm.
Plus you've got a base of X squared. You've only got one though because the top is open.
Okay.
And so just like we did in the previous problem, you're going to solve this one for y. Y is 32 over x squared. And that goes in here. So it's 4x, 32 over x squared plus x squared. And this is what you're going to graph and look for a minimum. So let me do that here. So let me go back to the graph. And what's nice with the graph is you don't have to actually simplify. I'm typing in 32 over 4x times 32 over x squared plus x squared. And then I get a, it just handles all the things that I might care about. So the minimum occurs when x equals 4, but we need the y value. So you get the y value from plugging it back into the volume equation. So the volume equation says y equals 32 over x squared. When x is 4, it's 32 over 4 squared, which is 16. So y ends up being 2. So I believe you can just write 4 comma 2.
Okay.
Might be an issue there. I don't know. I don't know if it wants x and then y. I think that's okay.
Okay.
All right, last problem here. Okay, so this is kind of a lot like the earlier problems here. I'm going to just graph it, and there's going to be a max, and that's the x value. This is asking for the x value, and the y, the other part is asking for the y value. So I'm just going to graph it, and then we'll get an answer for it without a lot of effort. So 7, and then you use x instead of t when you're graphing these on other tools.
Okay.
10. We already got it here. So let me snip that in. Let's say around. Oh, that's good. All right, so here's the graph. So when you look at the graph, it tells you, okay, there's my max. My max is after 10 days. And the percentage is 25.75%.
Okay. All right, I'm just gonna go through and check about my commas.
Yeah, were any of the numbers different? Anything?
I don't think so. I was checking, so I think we're okay.
Probably okay. All right, that is it. I do have to run here. So I know that was a little rushed at the end, but see you next week as usual. If
Yeah.
all right.
Yeah,
Thanks
no
so
worries.
much. Okay,
Thanks, Matthew.
have a great weekend. Bye now.